Greetings, everybody. Thank you for joining us today. We're excited to have you. But welcome to the State-of-the-Art Service Parts Management Webcast. Looking forward to our discussion today. By way of housekeeping, I'll run through a few items. First of all, my name is Bradley Roten, and it's my pleasure to be the host today in this webcast as part of our Servigistics webcast series. We're pleased that so many of you took the time to join us today from all over the world and representing a lot of different industries. We've got aerospace and defense, we've got high tech, medical device, automotive, oil and gas, industrial equipment, and many more. And we're excited to have so many of you joining from all over the globe. So welcome to all. We're recording this webcast. We'll distribute it later today to all of you, as well as those who couldn't join us live. We'll send that out later today. You can submit any questions to my email on the screen there, broten@ptc.com. We might be able to slip some of those in the webcast today. Otherwise, we'll respond to all of the questions directly, whether it's in the webcast or offline. Today, though, we're very excited to have three cream of the crop presenters. These are three very interesting, insightful, and experienced professionals. They're going to each present, and we'll have some cross-commentary throughout the discussion today in the webcast. Ed Wlodarski is with PTC Servigistics, and he's fondly known as the godfather of service parts management, having designed the first commercial service parts management solution back in 1990. And Michael Blumberg's with the Blumberg Advisory Group. He has more than 20 years of experience in strategic planning and market research, as well as benchmarking. And Dean Hurd with Capgemini is the director of their service supply chain practice. He has also more than 20 years of experience implementing service parts management solutions. All of them have a wealth of real world examples, use cases, and a lot of best practices that they're going to share today. And I think we'll kick it off with Ed Wlodarski. So he's going to give us a look back to the historical perspective of service parts management. And he's going to leverage his 4-decade career where he'll take a look back at where everything started, some of the implications of the evolution of service, and the implications that has on service parts planning. Then he'll also talk about some of the emerging technologies within the space that are really influencing service parts management, service business itself, like artificial intelligence, machine learning, big data, and IoT. So Ed, thank you for taking time to share your experience with us today. We'll turn it over to you.
Thanks, Bradley. Good morning, good afternoon to everyone. So as Bradley said, I'm going to take us in the Wayback Machine for a few minutes here. And while the topic today is going to be about state-of-the-art for service parts planning, I'm going to give us some background on how we got there. And it's an interesting journey. The term supply chain is attributed to a British newspaper, The Independent, in 1905. But the term service or supply chain management itself doesn't come into the lexicon until the 1980s. So what we're talking about is relatively new concepts. When I started, there was no such thing as a supply chain industry. There were no supply chain professionals. There were no degrees in supply chain. What we had was MRP, and an MRP, materials requirement planning, was really the only supply chain tool in existence, and it was specifically and very, very specifically dedicated to manufacturing planning. And essentially, it was a glorified bill of material explosion program that exploded a bomb and offset the component lead times and created a supply plan to ensure that the parts were there. MRP doesn't get interesting until companies like I2 in the late 1980s, early 1990s started incorporating production constraints into the model, which much more accurately represented the challenge of getting product through a factory by looking at scheduling and load leveling. But specifically to service planning, MRP's limitations are many. Manufacturing knows what's in the BOM. They know what the demand is going to be. It's called deterministic demand. It's fairly simple arithmetic. If you're going to make 100 of these and you need 2 in each one, you need 200 parts. And they needed every one of them to assemble the product. So So it really wasn't a particularly great challenge. Their philosophy was just in time. I want to get inventory in to my network to minimize the amount of time I own it and have to pay to warehouse it. On the other hand, service deals with what we call stochastic or probabilistic demand. And because of that, we have a just in case philosophy. We have to carry inventory in case something fails because we don't have a production schedule that we're marching to. And because no one could be profitable by carrying every part at every location that might demand it, we have a very, very different approach to planning. Manufacturing and MRP also only dealt with the current bill of materials and the current component revisions. Obviously, we have to deal with legacy products and the inherent interchangeability issues that comes with that. MRP used new parts. Many of our verticals lifeline is reverse logistics and repair pipeline, which MRP didn't comprehend. And if any of you have tried to implement service parts planning and ERP systems, you may have found some of the difficulties in dealing with repairable parts because inherently their MRP, which is the baseline for their planning solutions, really doesn't understand that concept. And then MRP dealt with a location. It dealt with a plant. Service, we have to deal with a network. And that network is dynamic. It's vibrant. Material moves around. We have material flows of replenishment and rebalancing and returns and excess recalls, none of which were comprehended within MRP. And so the story about service parts planning then really starts with Xerox in the late 1970s. The Japanese introduced low volume copiers, which Xerox didn't see coming. They had dismissed that market as not particularly viable, and they completely read it wrong. Demand turned out to be much greater than anyone had expected. And as a result, Xerox rushed product to market. They rushed the engineering cycle and the testing cycles. And because they wanted to stem the tide, they flooded their sales channels in every one of their geographies with this really not ready for prime time product. And very quickly, they realized they had a massive service problem and on a global scale. The low volume copier launch was a disaster. The products had many, many points of failure. And so what they ended up with was engineering, redesigning products in real time. And parts were being issued weekly, sometimes daily. So part chains were dynamic. They were changing all the time, which created huge problems for the field who didn't know which part they were supposed to be using. It's very difficult in those times to communicate to 5,000 service engineers around the world that a -2 has now replaced a -1 or a procedure for repairing a product has changed. And so it was a complete mess. And compounding that, the transaction systems weren't used to dealing with the revisions either. And so they couldn't identify which parts were being demanded. So they just knew a fuser roll had been demanded. But because of all the engineering changes, that could be one of 5 or 6 different parts. And so it was chaos. And unfortunately, MRP was what they would have called state of the art. So it was at this point, Xerox said, we have to fix this. And they assembled a team with practitioners from their global supply chain practices and academics, including Jack Muckstadt, who had a very long-standing relationship with the evolution of service parts management out of Cornell University, researchers and other interested parties, and they developed a set of requirements to become the first custom-developed solution for service parts planning. So I finished graduate school in '81 and started at Xerox and was put on this team. So service parts planning was born in 1981. I started then. So those of you who are good at math, this is my 40th year of working with this technology. And originally I was put on the team to validate the math that they developed, and once things were coded, to evaluate the results. And it was a profound change. It had great impact on Xerox and gave them much more control over the service problem. And the reason I take us through this story is because this original system called MPS, Material Planning System, very creative, it is foundational in that it not only was the first application to challenge specifically the service supply chain problem, but it also became the blueprint for the first commercial application because at LPA, we started with the requirements of the Xerox solution and grew things from there. So it really was the genesis of this industry we talk about today. But if we were to look at MPS, we would not consider it to be a particularly viable solution for state-of-the-art service parts planning, because so many things have changed in those ensuing 40 years. And so for the few minutes I have left, I'm going to try to bring us to the current state in terms of what we think is important and happening in the space of parts planning. So I'm going to talk about three themes. The first one is the focus of service shifts to the service customer. And this sounds intuitively obvious, but it really isn't. When I started, the focus was finance. We were given a budget, we worked within the budget, and there was no correlation between that budget and its impact on the ability to deliver service. And very often we see in organizations where the customer for the parts planning, which is a maintenance organization or a field service organization, actually have metrics that pit them against one another, where because the service delivery person wants to have every part everywhere so that they never have to disrupt their operation, and the materials people want to have as little inventory as possible because they're measured on the value of their inventory. So right from the get-go, we have not focused on the customer in terms of our goals. The second is the role service plays in an enterprise, and this is interesting too, and it's fairly recent, because for a long time service was considered a cost center. With Xerox, it was a cost of doing business. You didn't do it to generate revenue or to create brand loyalty or repeat purchases. You did it because you had to. If the copier didn't work, the customer was going to complain. But everything was done in a break-fix environment. But now people have realized the true role service plays in terms of its ability to generate revenue, and very profitable revenue, often more profitable than the revenue of the sale of the product itself. And so service now has a seat at the table that a decade or so ago it didn't have. And the third theme is about the availability of new advanced data science, and how, coupled with the ability to interact with the assets directly through an IoT environment, really create opportunities to transform how we plan parts today. Candidly, there's only so many features you can add to a system, and with an application that's as mature as ours, we've kind of hit that wall. What we needed to do was take a look at opportunities to innovate and change how people plan parts, not just adding another variable to a forecasting algorithm. And we'll talk about that in a minute. So what does it mean that we've shifted the focus to the customer? Well, we can see it in what their expectations are. While there's still a number of people who prefer a break-fix environment where they have a relationship with their service provider, where they just call an 800 number when their product fails, more and more people have increased their expectations with their vendor to have some skin in the game, some shared risk. And what that's done is spawned whole new business models around service level agreements, or in the defense world, there's different terminology for that. But the point here is we now have contractually binding relationships between the service provider and the customer, where there's some metric that represents the goals of the customer, whether it's uptime, availability, or response time, or recovery time. The service provider now has a very, very clear cut and contractually binding set of goals, and that's very different than the environment that I started out in, where you did as little as you could, you spent as little as you could, and you only changed things when the customer noise got louder. But these emergence of new business models are really, really transforming how service organizations interact with their customers. The implications of service becoming a revenue generator rather than a cost center is that it's got a much more strategic role in an organization now, where 20 years ago, we were never talked about in SI and OP planning because nobody really worried about the revenue. They just cared about some inventory number. And that's dramatically changed where we're a critical part of revenue generation. And therefore, we have some relationships in an enterprise that we might not have otherwise had before. And we have different stakeholders now. We have people in sales and marketing organizations that are driven to sell more service and recognize that service can be a market differentiator. Very often there are products that have fairly similar product feature sets, and it's reliability and maintainability that differentiate one from another and create brand loyalty and brand equity and repeat business. So service really does have a much more strategic role in the enterprise now than it ever had before. And now we have new technology. We've had the emergence of advanced data science for quite a while now. Things like artificial intelligence and machine learning have been around for a number of years, but we now have computing power and data storage costs that are low enough that they're practically applicable. They're not science projects anymore. They're actually things that we can use to solve real world problems. And for service parts planning, the Internet of Things gives us a whole different source of information. We like to break reliance on demand history and forecasting and use things like causal factors. But for many verticals, causal factors are in and of themselves forecasts. So if I'm looking at projecting what the install base would look like in the future, or what its activity profiles might be, well, connecting directly to the assets replaces that proxy data with real live data. We get to see how many assets we're supporting. We get to see what their operational hours are, what their activity profiles are, and we know where they are, which helps in deploying the inventory. And then what machine learning and artificial intelligence allow us to do is develop analytics sets that sit atop the traditional service parts planning world, which by definition kind of focuses part by part, and look at macro level things to look for systemic issues that the planning system might be able to address. And so I'm going to take a couple minutes here and then talk about what the implications of these three themes are for parts planning itself. And the first one related to focusing on the customer, it's very interesting. We measure the wrong thing very often. It's nearly impossible to try to correlate something like inventory turns with customer satisfaction. I mean, inventory turns was developed for consumer packaged goods to look at how many times the Coke emptied off the end cap at the grocery store. It doesn't lend itself very well to parts that are used 12 times a year across a 100 location network. And you can manipulate the data. You can load up on low volume or high volume inexpensive parts and drive up your inventory turns. But that's just to measure how many parts you have. It doesn't measure whether you have the right ones at all. In fact, you can manipulate it by buying the wrong ones. Fill rate has some of the same issues. It doesn't necessarily correlate to customer satisfaction. If you take your car to the service center and they tell you the good news is I have 9 out of the 10 parts, I got a 90% fill rate out of my parts window, but unfortunately I'm not going to have that 10th part for a week. You're without a car for a week. You're not happy. You don't care about that fill rate. You care that they fix your car within the window of time that you would expect it. And you can also manipulate fill rate data with the same things you could have with inventory turns by stocking high volume, inexpensive parts. The problem is the expensive, low volume parts tend to be the critical ones that keep equipment from being turned back in an operational state. And if you're not carrying them, you can have the greatest fill rate in the world. You're not going to have a happy customer. And as I already mentioned, we're now seeing new business models specifically because of that, because the metrics we have had didn't really correlate to whether the customer is being satisfied. So they've decided they're going to drive the metrics, and those metrics are being embedded in service level agreement contracts. And people are becoming ever more clever in terms of the different types of service offerings they have. Obviously, we have gradations like silver, platinum, gold type service. But what does that mean? What are the metrics? Am I focusing on availability of the equipment or response time by the service engineer, or how long it took it to get back up? But the point is, all of the metrics now and all those goals focus specifically on the planner. It was a very strange world for decades in material planning. And the reason I say that is budgets were established for how much inventory service could carry. And they were largely done by a finance community without any discussion with the customer, who is really the maintenance or field service organization, or the material planning people. And so the service parts planning guy got assigned a number, and he was monkey in the middle. There was no discussion that said, here's an exchange curve mapping level of service and availability. You put me on this dollar value that translates to this level of service. Mr. VP of Field Service, are you happy with that? Those discussions didn't happen. There was no forum to have a facts-based discussion. And in many ways, finance was considered the customer of the material planning organization, which is even further removed from the end customer themselves. And so now what we see is the opportunity to create optimization engines that create the roster of parts that meet those availability goals with the least amount of inventory. And we can constrain them with budgets if there's economic stress that needs to be represented. But the point is, the models are driven based on the current metrics as defined in service level agreements, as opposed to some of the inward-looking metrics that really didn't represent the customer. And service level agreements have a life cycle. We need to recognize that there's a whole host of analysis that happens up front in determining what I'm going to offer. What does a platinum level of service mean, and how is that different than a gold one? Is it a 2-hour, 4-hour, 12-hour response time? And so now we have stakeholders that using the output of service parts planning optimization to evaluate alternative service offerings based on their cost and therefore their profitability. And so the last part of this here is the Internet of Things and advanced data science. And history is a horrible indicator of the future for field service. There are too many cycles at play. There's economic cycles and calendar cycles and product life cycles, all of which really need to be comprehended, but history frustrates. And so we want to break that reliance on history. It's easy to understand why using demand history sustained for so many years. It's easy to understand, easy to compute, doesn't need a lot of data or computing horsepower, but it assumes yesterday looks like tomorrow. And all we have to do is look at COVID and the impact it's had on many of our organizations who had either demand spikes or demands fall off the end of a cliff. And demand history now would have them planning a totally inappropriate environment. So we needed something that was much more adaptable. And so we've had things like causal forecasting for years, but now introducing the IoT environment, we would now be able to see that equipment is being turned off, service level contracts were not being renewed, and break that into the model. And the other half of this equation is things like machine learning and artificial intelligence. And much of the analysis, as I said, happens at the part location level, and it has to, because that's where the rubber meets the road. But there are opportunities to take a step back and look more holistically at the entire planning environment and look for systemic issues. And that's where machine learning and artificial intelligence come into play. And we've represented them in our performance analytics and intelligence module, where we can take things like forecast accuracy, for example, and try to identify parts that may be suffering from the same issue, but are not in any way related to each other. For example, we may be systemically biasing a forecast high for this group of parts. We may not know what links those parts, but artificial intelligence and machine learning have found that they have a similar pattern. And we can then have the system tell us how to change the tuning of the engine to be able to better forecast those parts. So the future here is the opportunity to have the introduction of semi-autonomous planning, where while the system for a long time has been making recommendations at a part level for how to take actions, we're now making recommendations at an enterprise level to tune the model better itself. And that creates a very, very different future for service parts planning and the role within it. So Bradley, I'll turn it back to you.
That's great, Ed. Thank you so much. I appreciate that. I'll take back the slides, and we'll jump over to Michael Blumberg, and we'll get some of his thoughts. It's interesting to take that look back and consider where we've been, to understand where we're going. And Michael has executed recently some benchmark reporting, which can help us get a better idea of what's happening now. And it's also interesting, I think, if we consider those variables, we're also looking at this tsunami of technology that Ed just introduced us to with AI and ML, and it's interesting to see where that will lead us. So Michael, thank you for joining and sharing your expertise with us. We'll turn it over to you.
You're welcome, Bradley, and thank you for having me here today. And I want to say good morning, good afternoon, good evening to all our participants in this webinar. Just give you a brief overview of my background. I started working in the aftermarket service industry in the late 1980s. I joined a management consulting firm that my dad started back in 1969. And shortly before I joined the firm, going back to the early 1980s, the firm worked with AT&T. At that time, AT&T, many of you might know about the history, it was broken up. It was a monopoly. Government determined that they were involved in anti-competitive practices, that they had a monopoly, that they had to break up into these baby bell organizations. So AT&T and all the baby bells now no longer had 100% captive market. They faced competition. And in order to keep the customers, they had to ensure they were providing a high level of customer service and that they were profitable. And one of the areas that they focused on was making sure that the parts operation was running smoothly, it was profitable, because that's one of where their biggest cost, expense, and investment lied. And so our firm was brought in to help show them how to optimize their service supply chain. And then around the time that I joined the firm in late 1980s, lots of manufacturers were seeing the success that Xerox had, as well as IBM, where they were moving from a service as a cost center to service as a profit center. So our firm carved out a niche, helping manufacturers transition from a cost center to a profit center. In fact, my dad wrote a book called Managing Services as a Strategic Profit Center. And I contributed some of the research and wrote some of the chapters in that book. And we focused, and I began to focus on how does that happen? What kind of strategies do you need to have in place for a company to manage service as a profit center? What do you have to offer? How do you offer it? How do you price it? But also, what do you need in terms of an infrastructure to manage service as a profit center? So that's when I began my journey into benchmarking the state of the art of service management systems in general and spare parts management systems specifically. And what we also looked at was how many companies that are out there need this kind of technology. That's part of our planning process. And we shared that with our clients. Some of our clients became vendors. So that's how I met Ed at LPA. They were looking at how do they expand their focus, how do they accelerate penetration of the field service industry. They turned to us for that advice. And the word got out that we knew and understood this marketplace. And we started working for some of the ERP vendors that were evaluating whether they should build out a service parts management system, or they should acquire, or just continue to do what they're doing with their existing inventory management solutions. We also began to work for consulted private equity firms that were looking at making investments in this field, as well as venture capital firms. So, that's a little bit about my background. I've seen this industry evolve. What I think is just amazing to me is that some of the things that we had anticipated would happen, that we forecast would happen in the industry, have finally come true. We're seeing this happen today. We're right in the middle of some of the things that when I began my career, it seemed like this is years away. Will it ever happen? Now we see it happening. So let's continue here. So as many of us know, there's a number of unique characteristics of service parts management. I think I missed a slide. There we go. So one, as Ed alluded to, is that parts represent a significant aspect of the balance sheet and the income statement. In fact, they're typically the second largest expense item for a service company is the part managing the parts, and they're also the largest investment for a service company. And now the challenge is, we all know we have to have the right amount of parts at the right place at the right time. Otherwise, there's going to be a stock out. There might be penalties. It will impact customer experience, etc. But we can't carry too much inventory on the balance sheet because that will negatively impact our performance, our ROIs, and our income, and so on. So service organizations have to be very effective in how do you manage the spare parts so you can optimize many different goals. There's some criteria, some KPIs where you have to maximize them, where you have to do the best you possibly can, spend as much, for example, achieve the highest level of customer satisfaction, and others you have to minimize, like minimize the cost. And oftentimes those are in conflict with each other. So as a result, what I've observed in the service industry is this idea of CANFO, meaning continuing and never-ending focus on optimization. I think that's always been the case, and it always will be the case, is that service organizations have to continue to optimize. Optimize can be defined as making the highest and best use of resources. And in doing so, as I've said before, sometimes there's conflicting decisions you have to make. We have to achieve the highest level of customer satisfaction, but we want to minimize our cost. So to achieve the highest level, if we only had to achieve the highest level of customer satisfaction, we would stock as many parts as we possibly could fit into a warehouse or stocking location. But if we have to minimize cost, well, we can't do that. We have to make it lower. So what's the right decision? How do you optimize that? And it's not just about finding the best solution. I think it's about getting better and better at finding the best solution in light of a growing installed base, in light of new offerings, new developments, and new technologies that are changing what kind of data we have, how much data we have, and how we use that data for parts planning. I think this kind of validates and amplifies what Ed had said earlier, is that in service parts management, it's about just-in-case planning, not just in time. However, we still have some of the challenges that are associated with just-in-time. Is while we want to have just-in-case, we can't have an unlimited number of parts on hand. We've got to still achieve our financial goals of the company and our financial objectives. And a third unique characteristic is the impact of disruption on service parts management. So some of the disruption that we've seen, and again, I want to say that this is evolving. It's not that it just happened in the last 5 years. We've seen it happening I've been in this industry about 30 years, seen it happen over a period of time. And fortunately, all the folks on this panel have anticipated that and understand that this was coming and know how to deal with it. So one of these disruptions is servitization, and it's making parts availability even more critical. And certainly parts availability is critical to the customer experience, but even more so in servitization, because the contracts, the pricing, the revenue we get is all based on achieving a specific outcome. And that outcome can only be achieved through the availability of parts. If we don't make that outcome, some of these servitization contracts, we lose money. There's a penalty, more so than ever before. Another disruption we're seeing is the circular economy. Now, again, something that I've been in the forefront on. In fact, again, my dad wrote a book called on reverse logistics and closed loop supply chain management. So that's always happened. We've always had parts coming back through the service supply chain, through the reverse logistics supply chain. And in fact, we've worked at and encouraged companies to be better at managing those returns, that supply chain. Because if you have parts coming back for the supply chain, and you have a high velocity of return and velocity of repair, and you can get these parts back in your supply chain, forward supply chain, you can invest less, and you can make lower investments in parts. You cycle them through more. But what's happening is reverse logistics and the circular economy is becoming more and more important. So more and more companies are now investing in the reverse logistics supply chain, getting that inventory back. And as a result, they have to understand how to incorporate that information about what's coming back, when is it coming back, what condition it is, how long does it take to get refurbished, into their parts planning and forecasting. And the last one, of course, when we hear the term tsunami, I think many of us think of this tsunami of technology. So we've seen a lot over the last couple of years: mobility solutions, cloud solutions, AR, IoT, AI. And all that is, while it helps us get a better understanding of our installed base and how to solve problems, it also just creates so much data that we have to take into account in our planning processes. Another one I want to add is 3D printing. So while there's data involved, but there's also, that changes about how do we plan and forecast parts. If we can print parts on demand, what does that do for our planning scenarios? So what are the implications? Well, with all these complexities of service management, and operating in a dynamic industry, day to day, very dynamic, we really need automation. We couldn't manage these challenges, these trade-offs, these questions, these decisions today without automation. Particularly the bigger the supply chain operation, the larger the installed base, the deeper levels of inventory management and echelons, and the more constraints we have to manage against, like SLA constraints, the more and more we need automation. We just can't do it on a spreadsheet. We've got to have advanced technology that manages these issues. So what does that mean? What do we need to consider? Well, we need to consider that feature functionality is extremely critical. Not all SPM solutions are created equal, is what I found through this research that we've done. And it's a little bit different than some other applications we might see where, at face value, they all kind of seem the same. You dig in, they're kind of the same, but you really have to dig deep to see where the difference is. I don't see that with service parts management software. I see that you can really, by asking just a couple questions, by, again, reading, if you're not familiar, read our report, I think it'll become clear and obvious how these vendors differ on their functionality. And I think, at a high level, one of the things that differ is that some of these solutions were created specifically for service parts management, and they're able to handle the complexities of the service parts management, the different types of use cases that involve in service parts management, and the different types of vertical markets. While others did not go to that level of complexity. In fact, some of the solutions that are on the market today were not even designed for service parts management at all. They were designed for general inventory management, and the vendors are try to make them fit into a service parts management world. So that's one of the differences. And as I stated earlier, the complexities and nuances involved is what's important to understand. Can the software functionality handle these complexities and nuances? And I think there's two other ways to learn very quickly about the ability of the software to do that. One is, has any third party validated the math behind the optimization and forecasting engines? Because that's the core of service parts management. So you want to double check and validate that a third party actually validated the math. And another criteria to consider is, have there been any third party organizations, governmental, quasi-governmental, trade groups that have validated and endorsed the solution? Another implication is that because of these complexities, the expertise and experience of the vendor's bench is extremely critical. Does the vendor have experience and expertise in supporting a broad array of vertical markets, different levels of complexity, different types of optimization algorithms and forecasting and planning techniques? What's their philosophy towards service parts management? Do they see it as something you do as a profit center or something you do as a cost center? Are as part of that philosophy, are they investing in new tools or new techniques to improve service parts management, forecasting, and optimization? Are they able to support the broad array of complexities, as I mentioned before? And also, are there any experts from industry or academia that are involved in designing or developing the program? Or is it only limited to some college students that had a great idea, or maybe somebody that had worked in one company and said they designed a solution for that one company and that was it, that became the solution, and they really haven't made any improvements to it since then. So we undertook this benchmark evaluation study, thought it was really important. One of the reasons we did that is we wanted to provide service supply chain managers and executives with an understanding of what is the strategic value and importance of service parts management from a financial and operational perspective. And more specifically, we wanted to provide an independent benchmark and evaluation and profiling of vendors on the following criteria: feature functionality, vertical market focus, core competencies, use cases, and current and planned innovations. We wanted to go beyond looking at a vendor or set of vendors based on how many sales they had or what their market share was, but really dig beneath the covers and look at it from the standpoint of the functionality, what it can do, and who are the people behind it. So when we put the study together, we wanted to have a way of graphically positioning and portraying where these vendors fall. And we looked at two quadrants, two criteria. One was the product capability from the vendor, and the other one was the service parts management, innovation, and expertise of the vendor. And the factors behind that in product capability, we were looking at what's the optimization approach. Were they able to handle an array of optimization techniques involved in service parts management, ranging from single item optimization to multi-item, multi-echelon optimization, multi-indenture, multi-echelon optimization, and asset optimization. So the more of these optimization techniques a vendor could handle, the further they are on the product capabilities quadrant. We also looked at forecasting capabilities. Can they handle a range of demand forecasting techniques to predict seasonal, intermittent, and installed base demand? We looked at whether the solutions incorporate data sciences and the amount of artificial intelligence and machine learning capabilities that are integrated and are actually working and are being performed for customers. We looked at the depth of the features, the level of complexities of the features that the vendor's functionality. And lastly, on the product capabilities quad axis, we looked at the flexibility and ease of use. When it came to innovation and expertise, we were concerned with the vendor's vision. Are they keeping pace with the rate of innovation? Do they understand how well do they understand market trends, and what's the roadmap, and how frequently are they coming up with updates and new relations? We looked at what vertical markets are served, and lastly, what's the expertise of the bench. And Servigistics, we found, was among the most capable vendors because of their ability to handle the complexities and nuances of these service supply chains, and that's backed up by the bench strength. And we really see them as a heavyweight in service parts management. And as we'll learn in the next slide, the solution excels in all criteria under consideration. So some of the unique attributes of this Servigistics is the broad array of optimization scenarios, such as single item, multi-item, multi-echelon optimization, multi-indenture, multi-echelon optimization. They support a full range of forecasting techniques to deal with seasonal, intermittent, causal, and fixed demand, and they take into account sporadic and IoT data as well. Supply chain forecasting is very good, taking into account different types of supply chain sources. Uh, they've demonstrated their successful ability to incorporate advanced data sciences, and they've received independent validation from a number of organizations, including Logistics Management Institute, Capgemini, Boeing, and Lockheed Martin. And in short, they have the broadest and deepest functionality of the vendors we've evaluated. So with that, I'll turn it back to Bradley.
That's great, Michael. Thank you so much. We appreciate that. And we certainly welcome the analyst coverage in the service parts management space, something that we think is helpful and useful to those using the technologies, but also great for the market in general. So it's, I think, a great time to transition over to Dean Hurd, and let's get a different perspective since Dean's the director of Capgemini's service supply chain practice. He'll bring a different perspective. He certainly has a lot of real world examples and experiences to share in helping organizations solve some major service supply chain challenges. So Dean, let's turn it over to you. Thank you for joining us.
Thank you, Bradley. And good morning, good afternoon, good evening, depending on where you are. Happy to be here today. My background in service parts management actually started shortly out of college, though I didn't know what service parts management was. I was working for a suburban Atlanta school district that had just recently, thanks to the benefit of the Georgia lottery system, put a bunch of computers in each and every classroom, and nobody knew how to fix them. So I was blessed with the task of maintaining about 1,600 computers across 25 different schools. And service parts management for me meant looking in the box and seeing how few keyboards or mice or hard drives we had. And as far as data tracking goes, we had a very large whiteboard that we put stickers and dots on to indicate our demand history. Come a long way since then, fortunately. Tools and technology have evolved, and while I certainly didn't have the benefit of the groundbreaking experience that Ed had, I got in late in the game, but fortunately that experience taught me the benefit of proper spare parts management and making sure the right parts were in the right place at the right time, because there's nothing worse than a school administrator or a bunch of students complaining about the fact that they can't access their computer. So wanted to avoid that at all cost. But then again, cost was also an issue. And from the very beginning, seeing that balance between restrictive budgets and customer service brought into my mind the complexity of making sure that we give the right benefit to each of the stakeholders involved in a spare parts management scenario. I've had the good fortune of implementing some spare parts management solutions over the last 20 years and have been with Capgemini doing that for the last 5. And throughout that experience, throughout that entire journey, it is amazing to me how the entire industry has evolved from a software perspective. And it also amazes me how frequently the level of maturity that I see in many of these large organizations reflects that first experience that I had sitting in a cage in central stores in suburban Atlanta, trying to plan out enough mice, keyboards, and hard drives to support the entire school system. It's a low level of maturity that a lot of organizations still stick to, because the spare parts management groups have evolved, as Ed was talking about in the beginning, mostly from ERP planning. The same mentality is carried over into those organizations. So in the 3 major areas of spare parts management: forecasting, optimizing inventory and supply planning, we've relied on those same MRP-based techniques. In other words, using historical data and statistical analysis of that data, simple basic algorithms in order to predict the future. Inventory optimization has just been very reactive and based on like my original techniques with the boxes of inventory back at the school system, taking a look at what I have and just that, seeing that there's a certain number of days of supply on hand, and then reacting to that in a supply planning perspective by ordering whatever is necessary only when it happens. It's a very firefighting mode to go through service parts management in that, highly reactive, and yet some very large organizations, I'm not going to throw company names out here, but some large, high-tech, very innovative organizations are still in the somewhat of the dark ages of planning their spare parts in that particular area. Even their tools, the tools and technology are spreadsheets, hand-gathered data, hand-grown reports that don't focus on the automation and the innovation that is available with any good spare parts management tool. The result is error-prone, it's time-intensive, and certainly as the organizations grow, it might be okay in the beginning to just get started, but it's certainly not scalable. So what we have seen in more and more organizations is that we can progress from low to medium to high and get a lot of value by implementing any spare parts management solution. And what evolves is the process, the capability, and the outcomes as the tools and technology evolve, and data supports that as well. So with respect to forecasting, while statistical and historical forecasting may have been just enough in the beginning, now we have more data available. Causals are available. We can predict the kind of large-scale schedule maintenance that happens, and we can composite all these different forecasting methods together. Focus on the schedule maintenance bit for a moment. In a lot of industries, that schedule maintenance is critical. Think about aerospace and defense, think about automotive, and for that matter, anything with a large-scale asset that requires recurring maintenance. Historical tools just simply react, and we don't predict when that maintenance is necessary. So being able to schedule that maintenance through a maintenance bill of materials was a critical next step for a lot of organizations in forecasting. From inventory optimization perspective, rather than just being reactive and adhering to a days of supply perspective, we see that progression towards optimization, but still only at the single item optimization, strictly done by fill rate, and without necessarily balancing the cost and benefit of one part versus another. But at least now we're adhering to certain policies that go beyond just the, oh no, the box is empty, let's go get more reactive type of inventory optimization. From supply planning, we've gone beyond just that trigger-based method where we hit a certain level and then react and order more. Now we can stage the orders out over a long period of time and also gather inventory together and manage pools so that not every location needs to stock a part for a single that is lower volume and higher cost. We can perhaps keep that at a central store or regional location. So more innovation is happening to reduce the cost and reduce the overall investment of optimizing that inventory. And this is where we get into the next stage of tools and technology that we've been talking about here. There's automation, there's integrated data that is updated on a frequent basis. We have full visibility to our supply chain. We're not managing on spreadsheets, so we're scalable and we can do so through a user-friendly interface. And workflow management now becomes a thing. And you see the roles start to evolve here with people as well. Now we have more diverse roles and responsibilities when it comes to planning the spare parts and managing those. In some cases, the role between a planner and a buyer has now split. A demand forecaster and an asset manager has now split as people become more specialized in their area. But the final step in really bringing that supply chain, the service supply chain, to maturity is exactly the tools and tech that we've been talking about here. So instead of just causals being based on what we know from a data source, we can get those in real time. Every flight on a commercial aircraft now generates a terabyte of data. We can know exactly how much stress each part experienced, how many flight hours or cycles it experienced, and report that back in real time. So forecasting becomes, instead of just a bucketized month by month response to data inputs, the data analytics give us the ability to be much more predictive with the failures we are going to experience with those connected devices. Inventory optimization, instead of just being fill rate driven, gives us the opportunity to do marginal analysis, not only at one part in one location, but across the entire supply chain. You heard Michael talk about multi-echelon, multi-indenture optimization. That is now a possibility because of the type of tools and technology we have available. Supply planning, instead of just going beyond reactive and firefighting, or even proactive and being able to time phase, now we can do much more efficient exception-based management. We can plan to a multi-period budget report and optimize to a budget with various constraints, none of which were capable in the beginning. And then we can have the automation and intelligence also within supply planning to identify opportunities to disassemble old assets and reuse them, to predict the not only the repair of assets, but also the components that would support repair, and pre-position those repair components and optimize that all to a budget while still meeting our service level metrics that we need to. The tools and the technology have highly advanced, and I appreciate Michael sharing the analysis of the tools that are out there. It has moved far beyond the old days of spreadsheet. It has moved far beyond just a slick user interface. We now have AI and ML capability to be far more predictive. We have the large scale services of a cloud that allow us to do that heavy lifting and heavy processing of all of this data. The innovation of the tools has grown along with the innovation of the data, and there's so much more capable. Yet still so many organizations sit in the low to medium in a lot of these metrics, and having the tools such as Servigistics available to them has been one of Capgemini's driving objectives, is to move them from the left to the right. And as they do so, there's a great number of benefits. We see part revenue increases, we see availability increase, inventory is reduced, and overall, just the mere implementation of a mature spare parts management tool, even if not all of these capabilities that we just identified were leveraged, gets some great results. And typically we see an ROI within the first 6 to 9 months after implementation. And in some cases, in multi-phased implementations, I experienced this with a life sciences organization where it was staged between 3 geographic regions. By the time we reached the end of the third stage, the whole implementation was already paid for by the savings gained by just the first stage, the first region that we deployed. So in almost every case, just simply moving from the left to the right gives you that immediate benefit of part availability increase and happier customers, reduced inventory, and overall freight and handling cost as well. So there's tremendous opportunity for implementing these tools, and I appreciate the fact that, Ed, you were at the groundbreaking beginning of that to make it a possible opportunity for myself to participate in this innovation. And Michael, thank you for your analysis of the market of the tools. For me personally, I very much enjoy bringing this value to the organizations, and I appreciate the opportunity to talk about it here. Thank you.
Thank you so much, Dean. I appreciate that. Very good. Good to hear your comments and your perspective on everything. Well, in these last few minutes, I think we'll just take this opportunity to thank the presenters and just let you know that we can follow them through social media. All of them are on LinkedIn. If you're interested in connecting with them, you can find them easily through our Servigistics LinkedIn page. That's something you can see through our promotions for this webcast. We've tagged all 3 of the presenters in some of those promotions. You can easily connect with them there. We'd encourage you to do so. All 3 thought leaders, we thank you and we're appreciative of your perspective. Thank you for sharing that today. As I mentioned, we'll make the recording available and we'll send it out. We'll also post it online for on-demand replay. And other than that, we appreciate you taking the time to join us today, and hope you have a wonderful day.
Thanks.
Thank you, Bradley.
Thank you, Dean. Thanks, everybody.
Thank you.